Hi everyone, welcome to Irfan CFPS YouTube channel. If this is the first time you are visiting my channel, make sure to hit the subscription button below. In today's class, we will review different options for water sources that provide water to fire protection systems acceptable by NFPA 13. End of this session would be more interesting since we will look at hydrant flow testing procedure and shall plot hydrant flow test data on a hydraulic graph manually as well as using a software. Let's go. In today's class, we will cover various topics. Number 1, importance of water supplies. Number 2, factors affecting water supplies. Number 3, types of water supplies. Number 4, water supply flow test procedure or hydrant flow testing procedure. Number 5, plotting sample flow test data on hydraulic graph manually and using a software. Importance of water supplies. Water supply is a key decision component since all water-based sprinkler systems require adequate water supply to function properly. The effectiveness of any sprinkler system design depends on its water supply. In the event that the water supply fails to provide the required system demand, results in the failure of the system. Every automatic sprinkler system shall have at least one automatic supply. A risk assessment may show that a second water supply is needed based on the reliability of first water supply. Automatic water supply means that the activation of water supply does not depend on human intervention. The proper maintenance of water supplies for sprinkler systems is critical and is addressed in NFPA 25, which is the standard for inspection, testing, and maintenance of water-based fire protection systems. Let's look into our second topic, factors affecting water supplies. There are basically 4 factors which affect water supplies. Number 1, number of supplies. Number 2, capacity. Number 3, water supply treatment. Number 4, size of fire mains. We will discuss in detail about these factors. Number of supplies. For single building, only one water supply is enough. However, user may choose to install more than one water supply for redundancy. NFPA 13 designs are based on the assumption that only one fire will occur in a building at any given time and that the sprinkler system will control the fire before it spreads to adjacent portions of the building. Number 2, capacity. Capacity also affects the water supplies. Water supplies shall be capable of providing the required flow and pressure for required duration. Examine what may impact the water supply after the system is installed. Number 3, water supply treatment. Microbiologically influenced corrosion (MIC) can affect the system piping in the form of internal obstructive growth. Pre-installation water supply analysis and post-installation evaluation and treatment may be necessary. Number 4, size of fire mains. The underground water supply fire main must be sized to meet the demand of the sprinkler system, including host stream demand requirements. We can see a facility warehouse which has storage and non-storage occupancies. Here in this diagram, we can see the public water main, which is the water supply serving to all these buildings. And also you can find the suction tank and also the gravity tank. We can see here the public water main, which is coming from the municipality, is served to all the buildings. Our next topic will cover the type of water supplies. Selection of water supplies depend upon the geographical and topographical location of the building or structure. We will see today the various type of water supplies which are acceptable by NFPA 13. Number 1, waterworks systems. Number 2, tanks. Number 3, Penstock, Flume, river, lake, pond, reservoir. All these comes under one type of water supply. Number 4, recycled or reclaimed water. And number 5, the most important water supply is the fire pump itself. Let's throw some light on various type of water supplies acceptable by NFPA 13. Number 1, as we discussed, waterworks systems. Typically, a connection to public water supply commonly referred as waterworks system. This is typically a connection to a water main at the street level. These can be controlled or operated by municipal or private water company. A connection to a public water supply is acceptable only if a water flow test or any other approved method determines that volume exceeds peak demand. The pressure also needs to exceed the peak demand, but that can be increased by installing a fire pump. Water storage tanks, also an acceptable water supply. Water storage tanks are the tanks that supply water to water-based fire protection systems. Water tanks can be used for several different scenarios, but most commonly they are used where an adequate supply of water is not available or reliable. There are several types of tanks that can be used as a water supply, such as gravity tanks, suction tanks, and pressure tanks. Gravity tanks are the elevated water tanks that utilize gravity to provide pressure. They are not typically used. Suction tanks are mounted on the ground or below ground. Suction tanks typically provide water to a fire pump, which then boosts the pressure. Pressure tanks contain both water and air under pressure. When a system is actuated, the pressurized air pushes the water out of the tank. Because of this, a sufficient capacity of air must be available to discharge the water from the tank at the necessary rate. This is rarely used. Naturally occurring sources can be used as an acceptable water supply, which include penstocks, flumes, rivers, ponds, and lakes. Water supply sources such as these must be arranged to avoid mud and sediment being introduced into the fire protection system piping. These are thus required to include double removable screens or strainers on the water piping intakes. These naturally occurring sources need to be installed with a fire pump to provide adequate pressure for the system. The authority having jurisdiction should be considered or consulted when considering the use of these type of water supply sources. The most interesting acceptable water supply is recycled or reclaimed water. There is an increased interest in using recycled or reclaimed water as potential water supply for fire protection systems such as sprinkler systems due to increased interest in green and sustainable water usage and changes in weather patterns that results in drought. The source of the water and the treatment process must be analyzed to determine that any materials, chemicals, or contaminants in the water will not be detrimental to the components of the sprinkler system it contacts. The fifth most important acceptable water supply is fire pumps. Several of the water supplies discussed before utilized fire pumps to increase pressure. It's important to understand that fire pumps cannot create more water than is available from a given source. Fire pumps, they may be necessary, however, to make a water supply acceptable by increasing the available pressure. There are several other considerations that can help in the decision-making process of selecting an appropriate water supply, including the following. Corrosion. It is important to make sure that water supply doesn't have any corrosive properties. Dirty water. Mud and debris in the water will have a negative effect on the system. Number 3. Pressure variances. It is important to ensure your system takes into consideration the possible pressure variances caused by droughts, flooding, freezing, and usage of the water supply by others. And number 4, the most important consideration to select an appropriate water supply is water supplies needs to be able to supply water at any time. Multiple water supplies are not required but could increase the reliability of your water. Let's discuss the most interesting topic in today's session, hydrant flow testing or water supply testing. Water flow tests are conducted to determine the available water supply for fire protection purposes. Fire hydrants are tested regularly. All flow test steps are described in NFPA 291. NFPA 291 is the recommended practice for water flow testing and marking of hydrants. During a flow test, two hydrants will be considered. The first hydrant we call it as flow hydrant, the other hydrant we call it as residual hydrant. Flow hydrant is that hydrant which is used for the flow and measuring the flow during a flow test. Residual hydrant is the hydrant that is used for measuring static and residual pressures during a flow test. Water supply testing documents must include all these 9 things. Number 1, location and elevation of static and residual test gauge with relation to the riser point reference. Number 2, flow location. Number 3, static pressure. Number 4, residual pressure. Number 5, flow. Number 6, date. Number 7, time. Number 8, name of the person who conducted the test or supplied the information. Number 9, other sources of water supply with pressure or elevation. All these things must be included in the documentation part during the flow test. Let's move on with water supply flow test procedure or hydrant flow testing procedure. There are 8 steps in order to perform the flow test. Number 1, setup. Number 2, record static pressure at residual hydrant. Number 3, record residual pressure with flow. Residual pressure will be recorded at residual hydrant, and the flow will be recorded through a pitted tube at the flow hydrant. Step 4. Close the hydrants and measure orifice size. Step 5. Convert the pitted tube pressure reading, which is available in PSI or bar, to flow by using a formula. Step 6. Plot water supply test data, which is recorded. Step 7. Plot most demanding fire protection systems. Step 8. Analyze results for deterioration. Let's discuss the flow test procedure in great detail. Step 1. Setup. Notify water authority that you are going to perform the flow test. Have proper equipment, flow test kit on hand. As you can see from the screen, there are two boxes shown. One box is having 2.5-inch orange diffuser for pitted tube reading on the reference hydrant or the flow hydrant, and the other kit is having the pressure gauges which are used to measure the static and residual pressure at the residual hydrant, or we can call it as the test hydrant. Ensure that the drains are not blocked. From the above screen, you can see that the figure 4.4.4 suggests the test layout for fire hydrants by NFPA 291. There are 4 patterns shown here in the figure 4.4.4. In our case, we will take the first pattern, in which we will consider one hydrant as residual hydrant, the other hydrant as the flow hydrant. Flow hydrant can be called as the reference hydrant, and the residual hydrant can be called as the test hydrant. Diffuser is placed on the reference hydrant. Reference hydrant, as we said, is called as the flow hydrant as well, and the pressure gauges are placed on the test hydrant or the residual hydrant. Next step, we will record the static pressure at the residual hydrant. We will see a video showing the complete procedure to record the static pressure at the residual hydrant in order to understand very clearly. Initially, ensure the outlets at residual hydrants are tight, as you can see from the video here, and then slowly remove the 2.5-inch nozzle cap. Then you can see that the hydrant needs to be open. Slowly flush it until the water is clear. As you can see, the water is clear. Then we will try to close the hydrant fully. Later on, we will attach pressure gauge to the outlet. The outlet shown here is of 2.5 inch. Now slowly open the hydrant valve and take the static pressure reading. Let's discuss next step, step 3. In step 3, we will record the residual pressure at the residual hydrant along with the flow at flow hydrant. We will see a video which shows how to measure the residual pressure at the residual hydrant and also how to measure the flow by using the pitted diffuser at the flow hydrant. Let's start. Initially, flush the flow hydrant by opening a single outlet, ensuring all other outlets are closed tight. Slowly open the hydrant valve and flush the water, and then close completely. Attach 2.5-inch diffuser to the outlet. Now once you get the green signal from the personnel who is available at the residual hydrant, completely open the valve at the flow hydrant. Record the pitted diffuser pressure reading from the diffuser gauge and also record the residual reading at residual hydrant while the hydrant flow is flowing. Let's move on to step 4. Step 4 is to close the hydrants and measure orifice size. Once all the readings are taken and recorded, such as static pressure, residual pressure, and pitted flow, we need to close the two hydrants and measure the orifice size. We can use our hand to verify the type of outlet to determine the coefficient. We will see a video which shows how to close the hydrants and measure orifice size. Once the test has been finished, now we will convert the pitot tube pressure reading to flow by using a formula given by NFPA 291. Here you can see the flow formula in order to convert the pitot tube pressure to flow. Q equals 29.84 CD square root P. You can see where C is coefficient of discharge, D is diameter of outlet, P is pitot pressure. And also we can see figure 4.9.1, which shows the three general types of hydrant outlets and their coefficient of discharge as specified by NFPA 291. If the hydrant outlet is smooth and rounded, then the coefficient of discharge will be 0.9. If the hydrant outlet is square and sharp, then the coefficient to be considered is 0.8. And if the hydrant outlet is square and projecting into barrel, then the coefficient must be considered as 0.7. Let's take an example here. For example, in this case, we consider the hydrant outlet to be smooth and rounded. Then we need to consider the coefficient as 0.9. Let's write the formula here. Q equals 29.84 for C D square times root P. Now we have coefficient of discharge as 0.9 and D is the diameter of the outlet. We have seen that the diameter of the outlet from the hydrant is 2.5 inch, 2.5 inch, and we need to have P. P is the pitot tube pressure, which will be noted from the flow hydrant. Let's take, for example, pitot tube pressure reads 36 psi. Now we have all the three things which we need to calculate the flow. Let's see the flow available at the hydrant based on this formula. 29.84 multiplied by 0.9 multiplied by 2.5 inch square multiplied by root 36. We'll get around 1007 GPM. So in this case, the flow available is around 1007 GPM. Next, whatever data is being recorded during the flow test will be filled on water flow test report. As you can see here, NFPA 291 has given a sample report where we need to fill the complete site information, including the size of the main and also the residual hydrant pressure and the static pressure. Apart from that, how many tests we have conducted, that is shown here. If we conduct only one test, then the number of outlets we considered should be mentioned in this form: the orifice size, orifice coefficient, residual pressure, pitot pressure, and from the pitot pressure we'll be able to calculate the flow. This report has to be prepared and submitted for the approval authority in order to take the approval. Since we considered one flow hydrant, one is flow hydrant, the other is residual hydrant, we will note down the complete data here. Test number 1, number of outlets are 1, orifice size is 2.5 inch, orifice coefficient we considered as 0.75, let's say, and residual pressure, let's say we got as 55 psi. Pitot tube pressure, let's consider 25 psi for example. All this data has to be entered here and the flow to be calculated, which will be around 700 GPM. Apart from this, The size of the main has to be mentioned here. The location, test by, date, time, address, everything has to be mentioned in the report. Now we will plot the information as per the field report on the hydraulic graph. As you can see, the sample graph sheet shown here from NFPA 291. Based on the information from the test report, we will try to plot the graph for clear understanding. As we said, the static pressure we got as 75 psi from the residual hydrant. We will mark it here. And the residual pressure we got as 55 psi at 699 GPM. We'll mark it on the hydraulic graph. We can see the pressure is on the y-axis and the flow is shown here on x-axis. Now the residual pressure is 55 psi. It will be about here. We'll mark at exact location 699 GPM at 55 psi is the residual pressure which we got. Now we will extend this line and join with this residual pressure reading. Let's start. Next step. In this, we will try to plot the system demand. Now you can see on the screen the same graph sheet which I have shown in the previous slide. In this, we will try to write the project name of the project, location, test conducted by, date, time, everything has to be shown on the graph as well. Now what we will do, again we will mark the static pressure and residual pressure on this graph which is taken from the flow test report. As we said, our static pressure which we got is 75 psi. We will mark it here, and the flow which we got is 699 GPM at residual pressure 55 psi. So maybe it will come here. Let's join these 2 points. This will be the hydraulic curve based on the flow test report. Now, as we said, we will mark our system demand from the sprinkler system on this graph so that we will be able to understand whether the available water supply, flow and pressure requirements are satisfying to our system demand or not. Let's say, based on our hydraulic calculations, our system pressure requirement is 55 psi at 540 GPM, which comes around here, this point, and considering the hose allowance 250 GPM, let's say for ordinary hazard, it will be coming here. Then we will join these 2 points. We can see from this graph that this point showing the hose stream allowance, hose allowance, and the other point on the graph is showing our system demand. Now from this graph we will be able to identify that our system demand, pressure and flow is under the hydraulic curve which is drawn based on the flow test report. Hence, from the graph we conclude that the available water supply can be used for fire protection purposes. Step 8 is just to analyze the current test results of flow test to previous results. You can see a sample test report shown here, 2 different lines. One is of the current test, the other is the previous test result. From this graph, we can compare the current test results to the previous results to determine whether there is deterioration of the water supply. Now let's see, by putting all the information of flow test report in Mirfire software, which is already available in mirfire.com. Now let's start by entering all the data which is available. Water supply analysis software. in which we need to put the site information. I mentioned as Hyderabad, a New Malakpet. Date I'll put it as 14th February. Time, let's say 3:30 p.m. Performed by the person's name has to be mentioned, or any local authority if they have done this testing, we'll put their name. And static pressure and residual pressure, which we have taken from the flow test, needs to be entered in this column. Static pressure will put it as 75 psi and residual pressure as 55 psi. Now we need to mention the readings of the flow hydrant. Pitted pressure reading, which we have taken from the flow hydrant, let's mention as 25 psi. Number of outlets we'll consider as 1. Outlet dia will be 2.5 inch from the hydrant. Outlet coefficient, let's say 0.75, then the total flow would be 699 GPM. Pressure at fire flow, considering 20 psi, the expected flow at 20 psi would be 1208 GPM. Now, as you can see, the system information has also to be mentioned. We will put the system demand based on the hydraulic calculations of the sprinkler system. We will put it as 540 GPM at 55 psi. Hose stream allowance we will consider as 250 GPM. As you can see here, from the graph you will be able to understand the available pressure at 540 GPM is 62.6 psi. Now we will try to see the graph. We have mentioned the static pressure, here the flow and the residual pressure. This is the emergency response 20 psi pressure at 1200 GPM. We have drawn a straight line by considering all these pressures. Here we have shown the sprinkler flow and pressure. This is the hose stream allowance which we considered for the system requirements. From this graph you will be able to understand at the demand point the graph shows about 62.6 psi. It means our system demand is well under this hydraulic curve. In next class we will learn the type of sprinkler systems. There are basically 4 types of sprinkler system: wet pipe system, dry pipe system, pre-action system, and deluge system. And also we will try to understand the piping arrangements as defined by NFPA 13. Thank you for watching my videos. Every Tuesday I will post one video for you. I hope that you are enjoying my video series. Thank you. We'll meet with you with new topic in our next class. Thank you so much. Bye.